more than 30 Web3 startups who are hiring using our platform. To tell you a bit more about our upcoming events, we will be conducting more than 10 webinars on various Web3 topics. Also, we are conducting 5 plus workshops on weekends to educate students and professionals who want to learn blockchain development. And one of our biggest event is coming in the month of July. We are organizing a hackathon called Web3 Hack. So to get more information about these events and get latest updates uh, for them, please follow us on all of our social media platforms. I will share the links with you guys at the end of the session. So let's begin our today's session. So today we have our special guest, Chaitra Sringa. She is senior analyst and application developer at Accenture. Today she will be talking about basics of blockchain development and many more stuffs related to Web3. Now I hand over this virtual stage to you, ma'am, and thank you for joining us today.
Yeah, thank you very much, Anshil. Hi all. Uh, I would really like to thank the CryptoNaukri team and Pranyan for such a nice welcome and helping me to be a part of this wonderful webinar. So today, so here we have all assembled to talk about blockchain, and mainly further as we go down the line, we are going to land up with learning about Solidity and Ethereum blockchain. Mainly, we are dealing with that currently. Uh, but let me just share my screen so that we can kick off right away. Anshul, can you confirm if you are able to see my screen?
Not right now, ma'am.
Okay. Is there any permission that you're supposed to give? Okay, let me try window share. I'll just try window share. I hope it's visible
It's
now.
working, ma'am. It's working.
Yeah, okay, cool. Okay, okay. So blockchain workshop. So this is I'm hoping most of the people here are very new to blockchain. They're just trying to understand what is blockchain and how things work, and is it just like, or someone who would have just joined because they're interested in investing into, to start on crypto investing and to learn about Bitcoin. But before you actually even start, doing all that things, like investing is like a very big thing to do, right? It's like you're going to put your hard-earned money on something. So I personally feel like you really need to understand what is blockchain, because blockchain is a technology that is behind with all the cryptocurrencies right now that you're able to see. And not just that, that is the main exposure that most of the people would have got right now. But many, if I hope there are also few developers here who is like already established blockchain developers, or someone who want to become a blockchain developer, or someone who have just started the journey with either learning Ruby, or with Ethereum blockchain, using Solidity, or even with any other for the matter of fact, even Solana or anything like that. And they've just started learning, but not really sure on the entire concept, because you can't the topic is very, very vast, where you just can't grasp in every nick and corner of the topic, every nick and corner of the whole technology. I mean, okay, so that's the reason. Like, I think you guys also can gain something out of it, because today is where I'm going to let you know all the basic concepts, not like too deep. That would take a very, very long, it's like a journey. So, and since it's a very new platform, day by day, each time there are new topics that is coming into platform and shining, and so that it is like it is like it's updating every time. So it is not something like very constant or stagnant. It has not reached to that point. You have to be aware now when you are coming to this platform. You have to be aware that the whole technology is emerging. So there is always some new change that is going to happen. So there's always some upgradation each day, each concept, new things just keep coming up in the platform. So whatever currently that I'm going to talk about is going to be the basic concept. No matter what kind of upgradation is going to happen in the space, it is all going to stand on this basic fundamentals. Okay, these are some basic fundamentals that you really need to understand if you want to enter this space. Okay, so currently, this is today workshop. So today first, I'm just going to explain you on the blockchain technology, like the basics and all, and how the whole blockchain was brought into the world. Okay, and there are this main technology is having many sub blockchains or types of blockchains, you can tell. So in that we have Bitcoin. I hope you know it's Bitcoin is different and Ethereum is different, Solana is different, everything, many examples like that. And the other rest concepts like smart contracts, that is something supporting the Ethereum blockchain. So that is like the main building block of Ethereum. And how is what are the building blocks of a smart contract, for the matter of fact, on what platform it is built and what kind of platforms and tools that can be used. I hope there are few developers here. If there are any, probably you can just speak up, and probably you can tell on what platform, or if there, especially if there are any already established blockchain developers also, it'll be nice to hear from you, like on what platform you're working currently, and if anyone into Solidity also. Anyone there? Not exactly blockchain or any kind of developer who is working now. Okay, I think people are really very, very shy to speak up today, so that's fine. So me personally, I have been working mainly with web applications development for the past 6 years. And how I got into blockchain is mainly obviously the whole 2022, sorry, 2020 crash, where this whole bloom just blasted when it came to Bitcoin and things like that. And for me as a developer, I wasn't basically interested in Bitcoin, but when they started telling what is, I just came across just like a GK, and I started checking like. What the hell, what is this? When I saw the news, okay, so much talk about Bitcoin and stuff. And I just, so somewhere I just came across, probably if someone is a fan of Dhruv Rathi, you would have seen like what is a Bitcoin and how it's actually working and all. And that's when I came across this blockchain technology. I think that's when most of the people started learning about blockchain. Till then, it was like a very small topic to be discussed, or a very unknown territory that I can tell. But post that, like once I started first I was just trying to understand the technology, and then once I understood what was behind it and its importance and how it can impact, so I started like thinking about I just approached that in a developer point of view, and that's when Ethereum and smart contracts and everything was in bloom, and that's when I started my journey. Probably there'll be some people there, I think most of them would have started in the same way. So today I'm just going to show you on these how to do a smart contract. I'll just show you with few by slight example codes, so that you don't get you don't want to put all the concepts into your head right in one day. So that's I'm just going to show how the environments are going to work, how the tools are going to work, and what all tools will be basically using that can help us to talk with the Ethereum blockchain. And this ABIs, mainnet, testnet, EVMs, those are all that is coming under the Ethereum blockchain and under it concepts. So, these are the topics that I'll be covering tomorrow. Probably, like I can give a head start by the end of the session on these topics, so you will have an idea what you can look up for the next day. So, yeah. So, what is blockchain? Anyone want to speak up?
Next generation of internet.
That's right. That's nice. Anyone else? Any more answers?
It's the data with the chain link,
Data
like
with the chain
like a
link.
block of data,
Uh-huh, uh-huh.
like it like a linked list.
Yeah, okay, you can tell that. Yeah, okay. I think you know a bit of data structures. I hope you know a bit of data structures.
Yeah.
Nice. Okay.
Basically a protocol.
Protocol. Yeah, probably you can tell like protocol is the ones we are having protocol that we are going to use on blockchain. Okay, more than calling it as a protocol, we are having different kinds of protocols that we will use on blockchain. Okay.
So, blockchain are the blocks of data which are interconnected using the addresses of previous block.
Mm-hmm.
So, the transaction happens. The data of the transaction happens stores in that particular block, and the address of the block is linked to the previous block. So, it's from a chain of
Mm-hmm.
blocks. So, thus the name emerges as blockchain.
Exactly, exactly. Yeah. So that's the reason that is the whole I think he actually summarized the whole concept of blockchain, like a complete overview there, like how one data how the data has been bundled and it has been kept in a block, and how they are each of these blocks are being linked. He did I hope you understood when he meant how a address of one block is linked to the next block, so that we can go in detail, that you will understand as I go in detail. But that is exactly how a blockchain is seen. Okay.
लिंक लिस्ट टाइप का है ब्लॉकचेन.
Yeah, basically, so how it is going to be is, say I have a certain amount of data. So if you're familiar with any kind of database, basically it is just like a database, but it is a database that doesn't have
It's the most secured one, I can say.
yeah, yeah, exactly. It is the most secure one. It is nobody is authorized, like you can't tell that this person is completely authorized on this database. It isn't like that. It is That's why it is called like a distributed peer-to-peer ledger. Okay. And since nobody is going to nobody can claim the authorization.
Immutable ledger.
Sorry, I think someone spoke up.
Immutable ledger, no?
Yeah, yeah, exactly. It is like a immutable ledger where nobody can can come and corrupt the data, basically.
A blockchain is a distributed immutable ledger which is completely transparent. Like,
Yeah,
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 transparency is one thing, distributed is second, immutability is third one. So
exactly.
the main thing is that like blockchain is divided like the core three things in a blockchain, that is distributed, immutability, and transparency. This
Yes,
is
yes,
what the main thing is in
yes.
blockchain. Yeah.
And that is like the main reason why it's been so popular.
Yeah.
So
The transparency.
yeah, mainly it's the transparency
Yes.
where you can't just go there and claim the data or corrupt the data or
Yeah.
anything like that.
Yeah,
So
there's a chances, like that's why it's like more secure by using consensus protocols and all, like Byzantine 51, like
yes,
something.
yes,
Yeah.
yeah. That's nice. That's I'm happy. Like you guys know these things. So
Yeah, definitely. I just
Excuse me, ma'am.
we are doing
yeah,
research on
yeah.
that as well, so that's why.
What kind of research like you're doing on that,
Yeah, I'm doing on that. Yeah, in blockchain.
on blockchain itself?
Yeah,
Okay.
yeah, ma'am.
You're working on any particular
Yeah,
blockchain?
actually I'm into in blockchain, like Ethereum blockchain.
Mm-hmm.
I'm doing some research on that, and you know, think like to create something new in in that.
So you have started to work on Ethereum blockchain, like you have started using Solidity.
Yeah, definitely solidity for that.
Okay. Do you have worked on any kind of project?
Yeah, I have done. Actually, I'm working in one project that is actually kind of creating an ecosystem in which
Mm-hmm.
I can add some decks like decentralized exchange, as well
Mm-hmm.
as NFT and metaverse. So I'm creating such kind of an environment in one kind of thing.
Okay,
So
okay.
I'm
That's
working on,
interesting.
yeah,
Oh, yeah,
that's and
that's
I'm
very
creating
interesting.
I'm creating one ERC20 token, as well as for the reward thing, and
Mm-hmm.
also one ERC721 for the
Mm-hmm.
NFT thing,
For NFT,
and
yeah.
also and also introducing some kind of feature like staking, and also if somebody is interested in playing games, and once he entered, firstly he have to stake that NFT first to play that games, or something like that.
Mm-hmm. Oh, that's nice. That's nice.
Yeah.
Yeah, I think there was someone who was asking, like, excuse me, and were trying to
Yes,
talk.
ma'am, it's me.
Yeah.
Yeah, ma'am, I just want to ask that why we introduced blockchain, like why we needed this. Like we already have secure database, right?
Okay.
Yeah, in
So
the AWS also S3 is a data storage, and there are so many securities are there. Like we need key or something like that, right, ma'am? So why
mm-hmm.
we introduce this? We already have so many securities for protecting our data. So
Okay.
what benefit it will give us?
Oh,
Decentralized.
good question, actually. Yeah,
That's the decentralization.
yeah, exactly. So you
No,
are
I don't
having,
understand, ma'am.
okay, so you
What
are
he said, I
saying,
don't understand.
he told one of the like important points why we go for blockchain is decentralization.
Ma'am, I would like to add one more point.
Yeah.
Yeah, but
So,
ma'am, like in the AWS, like snowflakes, and there are already centralized data, right? In the data warehouse, it already centralized. So why?
Yeah, so okay, what he meant when he told decentralization is your AWS S3, whatever you're having blob storage, it is centralized data. That means you are controlling it, or someone who has the authority, they are controlling it. Whoever has the access to your blob storage or Azure blob storage or anything, they are controlling it. They can see the data, right?
Yes, ma'am.
So, but and if, even they are seeing the data, they have been authorized. So they can even they have even the access. There are certain access level, right? You provide when you're defining block for any block storage or anything like that. You give the person's ID and you're going to give the access to them, saying they can either view or they can edit, view, and even they can perform all the CRUD operations like create, update, delete, and everything.
Yes, ma'am.
Yeah, but in blockchain, there are certain platforms. I can't tell you that this AWS S3 kind of Azure Blob and all, they they are they are very useful for certain kind of platforms, but where when it comes to certain platforms where we cannot give out our data on any kind of we can't have any corrupted data in the ecosystem. So such kind of platforms, it requires blockchain.
No, like
So
corrupted data, it means like I read about S3 that you can only edit and store the data, right? So why we store the corrupted data? Like I don't understand.
okay. So say you're storing all our whoever are participating in this call. So you're storing all our names in your S3, and you have the authority to edit and delete your view and all. Okay. So say there is an entry saying me Chaitra. She has also been participated in this webinar. But say you okay, there is another person, okay, say Pragnashil. Okay, even he has got the authority, or someone from the CryptoNaukri. Everyone, they have the authority to edit and view. So one of them would have been like a traitor, or someone who wants to, or say someone who is a hacker, or someone who have exposed the whole WS3 keys and everything to some hacker. So then they are going to come in and they are going to corrupt the data. Obviously, they are going to destroy our data. So
So,
in
ma'am,
that
what's the
case,
guarantee that if we introduce like doing in the blockchain, there was no hacking in that?
so in blockchain,
Like
there are
every problem has a solution, right?
Actually, the blockchain technology doesn't, you can't hack the blockchain. You're hacking just the Ethereum smart contracts and all.
exactly.
And
This is the,
he also need to understand the difference between Web 1, Web 2, and the Web 3.
yeah, the
So,
generation of internet. You're just,
yeah. So
I
after
guess, you're
knowing
just
the
an
difference
SQL
between
guy.
these,
So you're doing more analytics like Dune analytics, if you know. Just search for it, then you know everything about analytics and all.
No, just my question is like that if we still have so many securities, like every day there are so many securities happening like in the app,
Joel,
then why?
I like explaining you something like if you're using Facebook, like Facebook is holding a database, right?
Okay.
And you're posting something in your profile, and you don't have a authority to, and behalf of you, the Facebook owner have a authority to delete it, right?
Yeah, that's correct.
Somebody use some or abusive language and something like then this kind of action will be taken by the Facebook owner or Facebook kind of stuff, that post will be deleted, right? Something like that. But in a blockchain, that is not happening. That is freedom of speech, as we can say. Your data is can't be deleted. You can only, you are the person who are delete. You can delete that. No other
Okay,
person
so
have
you
authority.
mean like if I build a app from the blockchain, so
Yeah,
I don't have the authority to delete someone
yeah.
else
It's
things,
that's
right?
why it's called immutable. Like
Okay,
nobody can
okay,
He's
change
I
that.
just,
understand.
Yeah. And the second thing, you are comparing from decentralized with centralized. If something is happening in the centralized thing, like क्या होता है कि जो centralized thing है वो down हो जाती है, बट जो हमारी ब्लॉकचेन है वो कभी डाउन ही नहीं हो सकती. क्यों? क्योंकि जो ब्लॉक्स है वो हर एक ब्लॉक डिस्ट्रीब्यूट हो जाता है दूसरी चेन में. आप समझ रहे हो मेरी बात? एक ब्लॉक एक चेन में नहीं होता है, मतलब अगर एक ब्लॉक क्रिएट होता है वो डिस्ट्रीब्यूट हो जाता है डिफरेंट डिफरेंट चेन्स में। तो जो हैक है वो भी नहीं हो सकता। क्यों? क्योंकि जो हैकिंग होती है, अगर हम हैक करेंगे तो एक ब्लॉक को करेंगे, बट जब कंसेंसस प्रोटोकॉल यूज होता है तो उसमें क्या होता है कि उसको जब वो वेरीफाई करता है, एक इसमें ब्लॉकचेन में एक वेरीफाइबल होता है जो वेरीफाई करता है ब्लॉक को। जो वेरीफाई करेगा तो उस ब्लॉक में वो पकड़ा जाएगा कि ये इसमें कुछ गड़बड़ है, तो उसमें कंसेंसस प्रोटोकॉल का यूज होता है। कंसेंसस प्रोटोकॉल में फिर उसको हम शायद उस ब्लॉक को डिस्कार्ड कर देते हैं, ठीक है। एंड दैट्स व्हाई कंसेंसस प्रोटोकॉल प्ले इनटू रोल, लाइक वो चीज हटा दी जाती है। इसीलिए हम उसको इसको बोलते हैं 51, क्योंकि 50-51, लाइक अगर 51% जो ब्लॉक्स हैं वेरीफाई करते हैं कि भाई जो ये चीज है, ये ब्लॉक है, ये सही है, तो फिर वो ऐड हो जाता है ब्लॉक। हाँ, ब्लॉक ऐड हो जाता है। अगर या समथिंग लाइक दैट। सो it is like impossible to hack every like 51% of block that is created. वो hack करना
You can't have so many people agreeing with the hacker saying वो
Yes.
correct है, you वो correct है, you can't have like that.
yes
अपन बैक पैक नहीं कर सकते,
बैक पैक नहीं कर सकते। तो ये पावर है ब्लॉकचेन की। तो सेंट्रलाइज में क्या होगा कि अगर मैं चाहता हूं तो मैं कुछ ऐसी चीज करके एक रिपीटली एक्शन करके अपने आपके सर्वर को डाउन कर सकता हूं, जो कि बहुत बार हो चुका है। यू कैन सी इन अ लॉट ऑफ हिस्ट्री अगर आप सर्च करोगे, पर ब्लॉकचेन में ऐसा हो ही नहीं सकता।
अगर 1000 बंदे हैं ना नोड पे,
आप समझ रहे हो मेरी
1000
बात?
बंदे नोड पे तो एक भी ऑनलाइन हो जाए तो भी अपना ब्लॉक रहेगा ही। पूरा ब्लॉकचेन का एंटायर डेटाबेस उस एक ब्लॉक के पास रहेगा। ब्लॉक मतलब नोड बोलते हैं उसको।
हाँ, नोड बोलते
हैं उस नेटवर्क में।
Okay, now I understand fully why.
Hi guys.
Yeah.
Sorry for interrupting, but can we please keep the discussion for the end of the session? Please continue the workshop.
Yeah, sure. So I hope you understood, like your friends were trying to help you. So the main concept is you can't have so many hackers being the majority, and in fact when the majority can decide that those people are hackers, they can eliminate also. Okay, they can just eliminate from there, from which will avoid them for further corruption of data.
Yes. उस ब्लॉक आई थिंक orphan block
blocks, yeah. Those blocks are called, say that he's a hacker and he tries to introduce this. First of all, when he introduce any kind of data to the blockchain, it must be validated by the majority of them, saying whatever data he's putting, wo correct hai. Whatever data, it doesn't have any kind of corrupted data and all. They kind of validate it. Only then it will be added to blockchain. Whatever transaction, whatever it done, it won't be directly added to blockchain. So majority of people, they take probably like as I go down in the line, you will understand what it is called. You will understand in the when I try to explain on the consensus protocol, proof of work and proof of stake. It's called as proof of work, and those differences also I'll let you know. So in case there is any kind of such data where it happens multiple times, we can even we have the power, all the miners have the power to even discard the block from the blockchain. So that's how the authenticity is maintained in blockchain, in the entire blockchain network. Okay, I hope it's been clear for you for now. Yeah, okay, fine. Okay, for someone who is like going to start right now, so let me back start up. So basically, I hope you have after hearing this discussion, don't get too confused. We can go step by step. So a blockchain is a shared immutable distributed ledger. So by this we mean like whatever data that is kept in that, it is being distributed. That means whoever is a part of this blockchain, they all have the same data. Nobody is going to have a small piece of data and not having the rest of it. So each person, each node of it will have the same data, that is, it is distributed, and it is immutable, as explained earlier, like it is transparent. Okay, so if I am having certain amount of data, the same thing for the next person, or the next node will be having the same amount of data. And in case anyone else is trying to add extra data, they can't add, because once it is into the blockchain, you can't edit it. Okay, and it is transparent. Whatever data is there, each one of us can see. And any one person, once it is added into blockchain, it cannot be edited at all. It cannot be destroyed. Okay, once it is created, it is created. That's it. No updation, no editation, no deleting, nothing. So that's the reason it's called as an immutable ledger. And it is shared, as told earlier, like it's, since it's a peer-to-peer network connection. So each one of us will be sharing the same kind of data, same data. Okay. So I thought like probably more than definitions, it will be able to easier to understand for you when I try to explain the use cases. So here are some use cases that I just found. I have picked up some. There are many use cases. I have just picked up some of it, and I have just added in my presentation, where you can see like when there is a concept of digital IDs. Okay, so I hope there are some people who are like there was one series about the Prison Break. Okay, I hope someone would have watched Prison Break. Any fans of Prison Break here? No one watched Prison Break. Probably it was way back then. Okay, there it- okay, let me just tell like how digital IDs it can be. So there we have Aadhaar card, PAN card, and everything. So if anyone wants to kill my existence, me Chaitra Shringa, I'm having an Aadhaar card, so it's Aadhaar card number, and PAN card number with biometrics and everything. If anyone can delete or corrupt my identity in India, because I'm citizen of India, so it can be done by the government of India. Okay, so because they have the access to all my data, all my IDs, and all my Aadhaar card, PAN card, and everything. They can still corrupt my data. Probably they can put a different photo, or they can kill my existence and make a new person itself, saying, "Okay, me, I have never been existed, but there's another person called Chaitra Shringa with a different face, or some other different face can be tagged to my name and my identity." Okay, that actually that's what happens in the Prison Break series. Anyways, so that's the reason, like I was studying for digital IDs. So there, that's where the concept of immutability comes into picture. So there is, if I try to put up a data saying, okay, me Chaitra Shringa, and this is my Aadhaar card, PAN card, and this is my biometric, nobody else can destroy that data when it is in the blockchain. Not even government of India will have the authority to edit it when it is in the blockchain. So that's where even the concept of voting also can take place. You can see there is like one person can happening to cast multiple votes for all this bribing, and during the election times you can see there are many such kind of cases that comes up. So since there is one person tagged with one identity, obviously he can cast only one vote. But with the current database, and with the current procedures that is happening in the system, so you can see there is always a chance of corruption. There's always a window for corruption there. So when I'm using this ledger, where I have my ID and my data that is registered in it, and when I cast a vote, there is already a data entered in the blockchain saying Chaitra Shringa has voted for so and so, and nowhere else in the entire space or probably like for the entire world, nobody is going to come and allow me to cast another vote, because in blockchain it is already verified that I have already voted for someone else. Okay, so this is one such like two examples that I can give you that illustrate immutable. So, okay, say healthcare. Say I have just gone to a hospital. Say I have some history with diabetics. Okay, I have got some treatment, some surgeries done there. So next, probably I was there in New York that time. So I come back to India, and here I start having some allergies. So here, when I go to hospital, I will have to tell my doctor that I had so and so procedures done in when I was back there in some other country, and unfortunately I have left all the documents related to that procedure right where I had stayed. I had just come to India for some visitation or something like that. So in such scenarios, like you can't keep carrying each and every document of yours everywhere, and and doctor, if he tries to understand whatever had happened to you, he'll just try to understand with an overview. But then he would, since you won't probably, if you had not known the exact name of the medications that you had received, he might give out some other medications, and it might cause even more allergies since he's not aware of your history. That is the main concept here. So when how blockchain can be used here, so that's where this shared distributed ledger comes into picture. So if there is already an entry in the ledger saying, okay, this is the history, this is my, along with my ID, there is an entry on my health is as well. So no matter where I go, I'm in New York, or I'm in Delhi, or I'm somewhere in Germany, it doesn't matter, because everywhere they can just verify my data using blockchain. So they can just go up and they can look up, and nobody else, even not me also, would have the authority to edit that data. I wouldn't have the authority, or in fact not authority, I can't delete the data itself. So that's where one of the major use cases that you can see. And the big use case now everyone are interested in is this payment transfers, that is the DeFi part. So again, since with all the transparency that is happening, so what I can tell is, here one concept that I can tell is, um, say if one person is giving me some $100, so before even transferring the data, they're going to check the balance, and if the data, if that amount is present, then he's going to then the bank is going to verify, and then they're going to transfer the data. But in blockchain it happens little different. That probably I can tell you much further down the line. But before kind of any payments done, there is always verifications done, and it is all under a centralized authority right now. So it is the banks that are handling each and everything. So when you're transferring some amount to a person A that is there in India to some other person that is there in US, there is this middle party involved, there is this third party involved, who can enable this transfer possible. But obviously they're going to take some part of it as commission. Okay, and you are also going to allow this to happen because there is only third party present there, and you're going to trust that third party. So when it comes to blockchain, this whole concept of third party is just erased. Okay, you can directly transfer whatever money you want to any other person in the entire world without obviously there is going to be some commission for as a fee, or in this case I can say as a gas fee. It's called as gas fee in blockchain. So you're going to pay a certain amount, and you're going to allow the transaction to happen where your amount to whoever party B that you're going to send it to. They receive the amount with a certain gas fee that you will be providing. But in this case, you don't have to trust any third party here. Okay, because it is all happening right in front of you in the network. You can see till what time, what is the estimated time for it to happen and everything. And it just there is no, you can just blindly send this amount, because it is directly like a peer-to-peer connection here. So there is no concept of there is like total trustlessness here. Okay, you don't have to um, depend on anyone else for whatever kind of transaction at any time of the day that can happen using this blockchain. And yeah, this is banking that I told right now. Real estate, and it's the same kind. It's because there is total transparency. You can see a property that is there, like if the data of the property is maintained, then you can see till what time to what time, who the owner was, who where it was, and till what time, and what was the layout of the property and everything. And if there is any changes made in the property as well, even that can be seen, if it was for rent or for sale or whatever. The whole history will be maintained, so you will know, and you will be sure of the authority of a property. Okay, so there won't be one or more than one authority where you get frauded into it. Okay, so to maintain the whole authenticity, you can use it. And to obviously the online music and internet of things, like as they told, we already have YouTube that is already running in a blockchain. Hope you know that, where you don't there the concept of this interesting thing is the concept of this ads is also very different. It is like here in YouTube you will be forced to see the ads that YouTube is going to put on it, but there you're going to pay for the ads that you want to see. Okay, you're going to pay for the things that you are interested to see in. You will just pay for the things that you're interested, and whatever the content it's there related to those things, only those things is going to appear. So in that case, you're not burdened with all kind of not interested things to be watched. You're going to just pay and watch for how much ever you want it. And whatever the whoever puts up the content, even it is like they're going to take that fee for whichever you are going to pay to watch it. So that is again, it is very clear, direct. Whoever is the watcher, they're going to pay, and whoever is the content creator, they're going to receive it. And obviously there'll be some kind of gas fee involved in each of these transactions. Okay, so Internet of Things is like another interesting concept, where there are some projects that is coming up using this concept of total maintaining the total transparency. So say you can see like there are some vegetables and fruits that are claiming like it's organic and everything, but you never know if it is really organic, or have they used any pesticides or fertilizers, or if though they have been if even though if they have used, what kind it's been used, you never know that. So Internet of Things is one such concept where it will help you to determine about all these things, like based on based on just scan, it's going to tell you based on its temperature, it's going to tell you if it's a fresh fruit, or if a spoilage has been already started, and how much is the percentage of the spoilage and everything and that. And with blockchain, obviously you're going to have the entire data of just one apple that you will buy, from the starting from the farmer to where and all distribution centers it has been to whoever has handled the distribution also. So you can see the entire data of it, and you can determine if it is like really organic or not, and if you really want to buy also. So that's the thing. So these are like the uh like just on the top of my head some use cases of the blockchain. So it just demonstrates the main features Okay, like what is blockchain, why is it needed, and all those things. I hope these things will help you out. Okay, so this is the exact concept that we were discussing, like what is this decentralized structure. Okay, so there is always yeah,
एक्सक्यूज मी
someone
मैम।
wants to talk. Yeah,
मैम आप फुल स्क्रीन प्रेजेंट कर सकते हैं क्या, क्योंकि अभी भी स्लाइड 1 में ही रुका हुआ है स्क्रीन।
is it so?
यस।
Yes, it is.
Yes, ma'am.
Okay,
Yeah, now it's visible.
now it's visible, right? Okay. Are you able to see on the I'm on the decentralized slide. Are you guys able to see that one?
Yes, ma'am.
Yes,
Okay,
ma'am.
cool. Yeah. So the main concept here, that I hope I get this clear to everyone. So no matter what we do, okay, so earlier I was just talking about these IDs that is maintained. So it is who is authorized for that, government of India or whoever is handling such kind of database. No matter what you use, WS, SQL, Azure, or whatever, even though it has a separate key, even where you can't take it and decrypt it and all, but still you, someone or the other would have the authority to edit, delete, and everything, right? So even like the voting concept, where you cannot destroy the data. So there is one or the other centralized person who is going to take care of it, who has the authority of it, and who can do anything. Okay, if he's a good authority, that's fine, but not everything is, roses. So if there is someone there who can corrupt the data, then, and if it is a higher authority, then who is going to be responsible for that, right? You can't question him, because he is the one who is head. So just like, to for a transfer of 10,000 from Delhi to New York, you're going to pay certain amount of money for the third party, even though you're not sure that if the third party is going to pay the entire 10,000 that you're going to give to him, to the party B that is there in the New York. But you're just going to trust him, saying, okay, fine. It's like you're giving your original 10,000, and on top of that, you're going to pay him extra, some say 1,000 or something, so that he'll carry out the transaction, and you're just going to blindly trust that person as well. Okay, so it is like, if that person is someone who is a fraud, then he can take your 10,000 plus 1,000 of your transaction fee, and he can, you won't have any authority to claim on him, right? So that is like the whole concept of centralized network. So even when it comes to this hierarchical the structure that you can see in companies and everything, where there'll be one person, authoritative person, who can control and do whatever he wants. So that's when the not everywhere, but that's where we are giving a window for unauthorized or uncultured behavior in the whole space. So to avoid that, like, we can use this blockchain, where everything is decentralized, where you won't have power or any control on one person. The whole authority won't be given to one person, as we were discussing earlier. So how it happens is, each one person in the whole network have equal authority, have equal power, have equal control on the entire network. So you don't have to be like, you don't have to be dependent on anyone. You can cast your own vote. If it is like, if you find whatever the transaction or the data that is coming into network, like, it is the right data, then you can say, yes, okay, I'm going to give it a yes, and I'm going to pass it, and probably, and I'm going to give a green signal for adding it into the blockchain. Probably someone else, my friend, someone from Nishil, he might feel like, I don't feel this is right. I think there is something fishy, and I'm not going to, agree. I'm not going to validate this to be added to the block. So if majority of them are telling, okay, we all agree with Pradneshil, and we are not going to add this data to the blockchain because we really find something is fishy, and we're not going to validate this. Then in that case, then nobody is going to add it to the block because it is all on the majority, and that you can see each person who has voted yes or no is considered. So there is equal power. So that's when you can see, like, here, each one of them is connected with each other of them. So it is not like only there is only certain group of people who is handling such blocks, or certain group of people who are handling so and so blocks, that you can, I'll explain further. But even if any one person says that it is corrupted, and the whole process of adding it to the blockchain will be dropped then and there. Okay. And even if it has been like added, they can cast a majority vote and they can delete it out. They can remove it from the blockchain itself. So that is like how this whole communication is, how is going to happen, because it's a peer-to-peer network connection. Each one of us is connected to each other of us, and this further we will understand when I try to explain on the blocks. So there is no concept of secrecy that is maintained. It's all an open book ledger. So any kind of mismanagement happens, it is been noted to everyone else in the blockchain. Okay. So you can tell, like, decentralized nature of the blockchain insists trust in the process, such that two unknown parties can directly interact and transact with each other. So that's the reason, like, no matter it is all like how, no matter who you are, if you're like a part of the node, then there is going to be a concept of unity when it comes. So that's the another biggest plus point when you talk about in this eco space, is that there is always a concept of unity where majority of them have to come together and cast a vote on it. Okay, they have to take a call on it. So no matter who you are, nobody is going to like judge you or anything. It is going to be like an open ledger where if you say yes, it is taken as a yes, and no, it's taken as a no. So that's the thing. And as I told, it is distributed, so everyone has equal amount of data, whatever data is there in the network. And nobody, once it's in the network, nobody, no matter whoever, how much ever blocks you or you would have mined, it is not determined by that. Nobody have the authority to tamper that data. Okay. And that's the reason, like, such kind of use cases exist for blockchain, like voting and healthcare, and especially payment and transfers, especially in the DeFi. That is like a major advantage of blockchain. Okay. So this is like a very basic view on how the whole blockchain technology works. No matter what blockchain you take, this is like the base thing. Okay. So Solana, Ethereum, or whoever it is. Okay. So basically, say I have some transaction that I want it to be done. Say, like, I have a balance of 20,000, and I want to transfer 10,000 to my friend Pradnishil in New York. Okay. So that case, say I initiate the transfer. Okay. I have a balance of 20,000, 10,000 to him. So once I initiate this transfer, the request will be gone, and the miners. Okay, who are miners? Miners are the people who are there with a good amount of hardware configurations, who can take your transactions, not just yours. Probably there are many people who are trying to do that. So they're going to take the transaction, and if they want your transaction to be added to the
Sorry to disturb,
network.
Chaitra.
Yeah.
Actually, slides are not changing.
Yes, ma'am. Slides are not changing.
Hmm, I think there's some issue. Let
No,
me.
ma'am. Now it's okay.
Yeah, I'm just trying to come back and go back again. So let me stop presenting and reshare again.
Okay.
Okay, you guys are able to see my screen?
Yeah, ma'am.
Any one of you just confirm. I'm just going to change the slide. So are you able to see that?
Yes, ma'am. Yes.
Yes, ma'am.
Okay,
Now
Full
it's
so
visible.
visible.
I think now we are good to go. Yeah. Sorry for the, my bad. I hadn't selected that whole window. Okay. Okay, so this is on,
Yeah, ma'am.
as I was telling, this is like
Chaitra, ma'am,
the,
now
sorry.
what is it?
Okay, this is the basic layer of how the blockchain is going to work. So as I was telling, if there is any transaction request that I have done, so say I have placed the request, and now uh, a miner is someone who's going to take the transaction and he's going to include in the blockchain. So he's not going to come and like, acha chalo, Chaitra wants to just transfer, I'll just include. No, he's not going to do that. In order to do that, the major challenge is he will have to do some computational, he'll have to solve certain puzzle, I can tell, some computational answers that he will have to provide to the system. And based on that, once he's able to validate it or if he's able to solve it, based on that, he will be able to add my transaction in the block. Okay, so once he has just added my transaction in the block, then it has to be verified by everyone else who is a part of the network. I hope you're trying to understand this, because this is like a very important concept that you really need to understand, and there is no easy way to tell, because without understanding this, there's no way, like, you can't, like, deep dive into the technology. Okay, so I'm going once again. So there is any transaction that is happening. Transaction doesn't mean just like a money transfer. That I'm just telling as an example. It can be even like I'm trying to put my health history into blockchain. So that is a transaction. I'm trying to feed some data into blockchain about me. So even that is a transaction. It can be of any type. Okay. So say I have requested. For now, let me take the money transaction. So I have requested for the transaction. So what is going to happen? There are certain people called miners. Miners are someone who have very high qualified systems and all. Earlier it was there, but now it has been bit reduced. But these miners, they have the power, or not, I can't tell power. They have the requirement, facilities that is needed to add a block to the blockchain. Okay, and in each of the block, they are going to put this data. So whatever transaction that I'm going to do, they need to put that in a block and add that block to the blockchain. So in before doing that, he just can't take the transaction and put it in a block. Chalo, okay, she has some amount and I'm going to add it to the blockchain. They can't do it that easily. They, as miners, they have to mine the block. Mine the block matlab, they'll have to do certain computations, okay, in order to add that to the blockchain, to add the block to the blockchain. Or they'll have to validate it, and then only they can add the block to the blockchain. So once, say, here you can see a transaction is broadcasted to peer-to-peer network that consists of computers, otherwise known as nodes. So each of these miners, whoever has a system, basically any system that is a part of blockchain is called as a node. Just just keep this definition. Okay, any system that is a part of the blockchain is called as a node. So in some nodes can be just users. So I am someone in the who is a part of blockchain, who is just using like to get the data and all. And there can be someone like for you, you might be a part of blockchain, but you have the required hardware where you can uh, mine the block, where you can put you can mine a new block and introduce into the blockchain. So not all nodes are miners, but all nodes are a part of blockchain network. Okay, that you need to keep in mind. So when this transaction is initiated, it is being broadcasted across all the nodes. So everyone is aware there is a request for the transaction, and whoever is miners or the nodes who are miners in the network, they are going to validate the transaction. How are they going to do? Again, based on which I'm going to tell further, they're going to use the concepts of proof of work or proof of stake based on the consensus protocol. They are going to mine the block along with this protocol, say basically validating or we're doing some computational trying to figure out that puzzle. So once this the computation has been done by the miner, he is going to add the block to the blockchain, but it is not going to get added immediately. How? Because it has to be verified by the majority of the other miners that are there, saying, Acha, he's trying to add the block to the blockchain. Let me verify whatever he has done is right. And in fact, that verification won't take time. So it was just like I had just heard in one of the videos saying, like if someone is trying to solve a problem, they are going to consume more time than someone to verify if the answer is right or wrong. It won't take much time to just verify it, because everyone will know the answer. It's only the person who is going to solve it, he is going to take the time. So that verification is going to happen by casting majority of vote, and they are going to verify and they are going to tell, Acha, okay, whatever he is trying to add the block saying Chaitra, she is going to transfer 10,000 to Pradnyashil, who is there in New York, and Chaitra has the balance, and he's a correct receiver, she's a correct sender of the address, everything is fine. So Acha, fine, now you can add this information to blockchain. So once the majority have given a go, then the transaction is then been added, whichever is added to the block, that block will be added to the blockchain. And once my transaction is been added to a block that's attached in the network, I'll get a notification saying, now my 10,000 has reached to Pradnyashi in so and so with so and so gas fee involved in it. So always any transaction that happens, so it'll be including gas fee. So when you're trying to make any transaction, you can see how much gas fee is going. So the amount, though even though it has been reduced to a very great extent right now, so that amount is the extra amount that you will be paying for whatever transaction that you want to make in the blockchain. This is no matter what kind of blockchain, this is how every transaction is going to happen. It doesn't matter money transaction or anything, even storage of data or viewing any kind of data. That is the example that I was trying to illustrate using YouTube. So you spend the the content creator, he's going to make a YouTube video, he's going to spend some gas amount of fee and he's going to add in the blockchain. Even that data is being verified, or that data to be added in the blockchain is being verified by the miners by doing some computations. And then once it is added to the blockchain, whoever is the viewer, he's going to pay certain gas fee because that is his interest interest of topic. So he's going to pay certain amount that is again going to get paid as a gas fee, but that is going directly, some part of it is going to be as a gas fee, and some part of it is directly going to the content creator. So in this way, the whole concept of, now the centralized network is YouTube. Okay, so he is going to distribute, he's going to keep certain amount for himself, that on which he runs ads, and some amount he's going to give the content creators. Here there is no centralized authority. Whoever is the viewer, he is going to pay to the content creator directly. So there is no third party involved, no matter what, in any of the use cases. Okay. So this is like if you have questions on like still like the data, probably only data is going to be there, then all blocks will have certain amount of data and they'll be linked. But how are these blocks linked to one another? It is not like one block can have linked to more than many other blocks. It is going to be linked in a very linear fashion. Okay, so here is one basic concept that you need to know, like what a block contains. Okay, every block will have a header. So in that header it will have the block number and what is the previous block hash. This I'm going to explain when when I'm going to tell how each of the blocks are linked. Okay, and this Markle, I think I'll just leave it for the day, because for someone who is quite aware with data structures, they will know on that. This is just a concept where it illustrates how each of the blocks are being linked. Okay, and how the data inside it is being stored. Okay, and noise is just a number. Okay, this when a miner he's going to mine a block. So he's say, okay, say now other 10,000 that I'm trying to give it to Pradneshil that is there in the New York. There is one miner somewhere sitting in middle of South Africa and he's trying to mine it. Okay, and what he's going to do, say there is some 2000 or 2200 blocks are already there in the blockchain. So now he's going to mine 2201th block. Okay, in so the block number is going to be 2201. Okay, and what will be the previous block hash? So whatever the 2200 block is there, and the data that is stored in it, whatever the data might be, so the data will be encrypted. So those encrypted probably using SHA-256 algorithm. So there are different algorithms that is used for encryption of data. So it will create like an hash. Okay, the hash will be like depending, it might be a 32-bit or a 64-bit kind of a alphanumeric characters, which will have the entire data. Okay, so this SHA-256 algorithm that is used to encrypt the data, using these are such kind of algorithms where you can ask me why SHA-256. Okay, I'll tell you why. Because this algorithm is basically like you can say I am Chaitra. Okay, and it is encrypted. Once using the same kind of algorithm, you can't decrypt it. Okay, using the same kind of key you can't decrypt it. So it is like a one way concept. Using this, you can't see, say 2 into 2 threes are 6. Okay, okay, now 6 divided by 3 you are going to get back 2, or 6 divided by 2 you are going to get back 3. Are you able to follow this? So what I'm trying to tell is there is no concept of this backward answer using this algorithm. You can't figure out what was the two variables that was used to get the result 6. Is it 2 into 3 or 3 into 2 or 3 into 3 like that? Okay, I hope you're getting my point. Or sorry, 6 into 1. You can't get back, right back and get what was that A into B, what is that A and B to get the answer as C. You can only when it only the forward way you are going to get the encrypted value, not from the backward. That's the that I don't think many of them know this. Probably you can check out book about blockchain. um, I think I have it in my references here. Okay, I don't have that. I'll just ping you. I'll ping you the who is the author. So it's called
Given what
Mastering Bitcoin. Yeah, by Andres. Okay, it is like the Bible, the exact Bible. Whoever is interested, who wants to learn about blockchain, I just recommend you to start reading that book. If reading books is your interest, you can learn on all the deeper concepts. Okay, on how this basically how even this hash has been generated, what kind of algorithm and why this algorithm only, and what are the factors are considered when generating the hash. It's called Mastering Bitcoin by Andres. Okay, that is like a big Bible for uh, blockchain. Okay, and even he has another book, Mastering Ethereum. That even that book is so great. Each of the concepts explained very much in detail. You can just go through it, and it's going to help you a lot. Okay, so this is how each and then at the body it is going to have the data, whatever data that I'm going to include. So here is like someone was telling like a linked list, just like that. It is going to be one block is going to be linked to another block. So how it is going to link by using the previous hash. So say I have no a data encrypted saying I am Chaitra here, and here it is going to have the hash that is the encrypted version of this data, whatever the hash number it will be there. It is going to have the data here. Previous block hash. You can see this whatever hash has been generated for this one. It is the same hash that it will be storing in this the next block. So if someone comes or along the way and they try to like they try to corrupt it saying, okay, it's I am Chaitra, let me change it to I am Pradnyashil. And if they try to change that, it is going to generate a different hash. It's not going to generate the same kind of hash. Every character, whatever sentence you put in, it will, no matter what, it is going to generate the same set of alpha numeric characters. Okay, so in case there is any change, even with if it was I am Chaitra dot or full stop, even that is going to generate a different kind of hash. So if there is any kind of change in the data, it is going to change the hash, and hence it won't be able to link to this block, because you can see there will be a conflict. This is having a different hash, but in this block we are storing the previous block hash as a different. There is a mismatch, so in that case, they're going to drop the entire block. And this is how the whole concept of hacking is being handled in blockchain. That is why there can't be any hacking that can take place in blockchain. Because if there is any whatever data we put in blockchain, it cannot be deleted. But if someone goes and try to change the data, then also it cannot be retained in the blockchain, because if there is change in the data, there's going to be change in the hash, and if there is change in the hash of any particular block, then whatever the rest of the blocks that is linked to it, it is not going to agree with that, saying whatever the previous hash that they have doesn't match with the changed data, a changed hash of this block, so they're going to drop this entire block. Okay, that's the reason it is impossible to hack blockchain network. Okay, so this is how the entire thing takes place. Now, another main thing that I would like to tell here, before I go to this proof of work, anyone having doubt up to here?
Yes, ma'am. Can you explain this part again? Like this block part?
What part of it you couldn't understand?
Ma'am, you said na that like we change something like dot or at the rate. If we change little bit, it will
Mm-hmm.
change the hash map shape. Then can you
Mm-hmm.
explain it with the example?
Hmm. Let me explain. Online, probably I have forgotten is password generator, online generator. Okay. Okay. This is a online hash generator that you get. I think anyone can just Google it and they're going to get. Say now in one block, I'm going to enter data. Say I am Chaitra. Okay, this is the data that I want to enter into the blockchain. So when I put the data in the blockchain, how it is going to store it as is going to apply the SHA-256 algorithm, and then it is going to generate a hash. Okay. So if you here you can see this is the hash that is generated for this data. Okay. So let me copy it and then I'll just put it in a notepad. Okay, this is just the set of alphanumeric characters that is there, um, which is 64 characters. It is going to store this data. I am Chaitra. Now, say someone else comes up and they want to change the data. They're going to tell, okay, I am Pradmeshi. Okay, Pradnya, whatever. Okay, I'm just going to change. Or say even okay. So if they try to do this, so what is the hash that is getting generated? This hash, right? So now you can see is this hash and this hash the same? No, right?
No,
Yes,
it
So
is
it's
different.
so the exact thing. So say in this block now I am Chaitra hash. Earlier it was this 40, this one. Now someone has tried to come and they're trying to change the data for which the hash is this 7C4 CF. So what is this block number one? What is it going to tell? Acha, my earlier or the previous hash that I had saved when this block was mined, the previous hash that I had got was this one, 4074. But now, how come the hash that my previous hash is not matching to the hash that is present in this block one? Sorry, in block number zero, it is having a different hash. So that in that case, it is not going to accept. कुछ तो गड़बड़ हुआ है, like that. It is not going to accept my previous hash. It is showing 407, but this block is having some other hash. So there is something wrong, and it won't accept in the network. Okay, so in that case, the miner or whoever the hacker who is trying to change the data, he won't be able to change the data because it is not getting validated across the miners. They're not going to accept it. Okay, so he's going to tell, Array, no bhaiya, this block number one, it says previous hash to be this 407, so we can't validate this. It has a different hash. So that's the reason we are going to cast no. And then and there the whole concept of trying to hack, it will get ended there only. Okay, because it is very clear that the block one is having a previous hash as a different hash. So it is not only this. Even if there is any small change, okay, say now I'll just put Chaitra. Okay, you can see this was the earlier data. This is the same hash that I demonstrated in the first case. If you compare, each and every character is the same from starting 407 to ending 163 EF. Okay, each and every character. So each and every time I put this data, I'm going to have the same hash generated. Okay, so in case if there is any one character change, say I am Chaitra, full stop. I just added full stop, but you can see this hash. You think this hash is the same as the I am Chaitra hash? See, just one full stop is going to change the entire hash. Each and every character is different. So that's the reason even the hacker can't hack, because he can try thousands and thousands times of trial and error method trying to crack this, trying to get this nonce and block number and the data and all this thing in the right way, whatever data hash you would have added in the block, he might try 1,000 times trial and error, where figuring it out is very, 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 very possibilities very low. Okay, because he has to, sorry, because he has to, when he has to hack anything, even on basis of trial and error, he will have to get the hash right, he'll have to get the block number right, he'll have to get the nonce right, the previous block hash right. It is close, very close to impossible to get all these things right and hack into the system and change the network or anything for that matter of fact. It is almost highly impossible to happen. And such kind of trial and error, by that time, the more blocks would have been added, and he can't keep coming back saying the same noise, or even that there's another concept of timestamp saying at what time this block has been mined. Even all these, he can't beat it. Okay, that's the reason it is impossible to hack blockchain, even on the basis of trial and error or AI or whatever you use. It is not possible, because once one small change in the data is going to reflect a different hash. And even if you get the same data, you will have to get every other attribute that is there apart as a block. Each of it should be right, which is highly impossible. That's why it is the most secure network. That's why blockchain is called as the most secure network and the most transparent and immutable ledger that ever exist. And that's the reason its use cases is so wide. And uh, I can tell you, or like I can promise you that further, with such kind of fast forward technology that is happening around, even the hardware has been so much improved that if you go across and check what was the earnings of a miner earlier and how much he's earning right now, and right now, like you have the concept of, there is a limitation saying there are, you can only mine up to like you can have only up to 21 million bitcoins. It is almost reaching. So it is going to again rewind back. That's the reason this supply and demand, it's been maintained across. So this whole concept of blockchain can be applied to any kind of use case. It might be economic, social, or even for the matter of personal, anything, in anything in the matter of society. It has such a wide use case, and such high transparency, and a complete trustfulness that it can beat any other system in the world right now. So that is the main scope of it. This is the main reason, this is the main fundamental why it has such wide use case, why it can be used in any other platform. Because every data is so transparent, and the kind of algorithm that is used, it is like one way. You cannot again put back the same algorithm. You can't put the same algorithm and decrypt it. And if you say that, what I mean by saying that is, I can't put this, say now I am Chaitra, I'm getting this as the hash. I can't put this hash and get back my data. That is the whole concept of this algorithm. I can't put this, and again I can't apply inversion of SHA-256, and just like how 2 into 3 is equal to 6. I say 2 3s are 6, 2 into 3 is 6. Now if I inversion of multiplication is what? Division. Now if I try 6 divided by 3, I will be getting 2. But that kind of inversion concept cannot be applied here. Even if you apply inversion of SHA-256, or for the matter of that, all these algorithms, you cannot get back these characters. So that is why it is used for, it is called as such a secure network. I hope I answered your question.
Yes, ma'am. Like, what if we want to change, like you written I'm Chetra, and we want to update it? So how can we update our this afterwards? As you
That
said
is
now that
Yeah, that is like another one thing. Like this whatever data that is the reason you have to be even very careful when you're putting data into blockchain. Whatever data once it is put, it cannot be erased and it cannot be edited. So that's the reason you have to maintain it. Even for the matter of fact, when it comes to Ethereum blockchain, even the smart contracts, once it is deployed to the mainnet, to the Ethereum, it is highly impossible to change it. And that's the reason we had so many controversies earlier, like the one person was talking about what was it, the DAO attack and all that. That is like since the main advantage of it is immutability. You can't like go against that feature. You can't change it at all. In if you
So, ma'am,
have that,
it's like a disadvantage.
you can't tell that as a disadvantage, because I am going to put the data that is going to be constant, right? Probably I can, if okay, now my name is Chaitra. Now if I go and change my name to Pradnyashil, then probably I can come back in case I can update it, saying up to 2022 my name was Chaitra, and then in 2022 I went to the court, I applied for change of name, and the court it granted me that my name change is possible, and it changed back my name. Whatever the certificate I get, I can upload that to blockchain, and then I can tell from 2022 so and so till now my name is Pradnyashil. So in that case you can update it, but you can't edit it. I hope you are understanding the difference between editing and updating. Okay, if your present score is like, your present experience is 5 years, then by the time of next year your experience won't be still 5 years. Am I right?
Yes, ma'am. That's what I'm asking. Like, how do we update? Like, we have some key or like anything.
No, it is going to be the same way. Say, like in so and so blog, your data will be there saying, my name is so and so, and this is my experience. So, like every time you send a request, just like a transaction request, so you can tell, okay, by up to here 2022, I have 5 years of experience. Now 2023, it is going to be 6 years. So you can send a transaction, or for the matter of fact, even your name, change in your name, you can send a request saying, this is the data that I want to put up on my identity, that my name has been changed to Pradnyashil, with this, and as a proof of it, I have so and so certificate, and obviously it has to be the original one, whatever you're going to update it. And with that, again, the same way, however it has been mined, it will be any transaction will get mined, it will be added to the blockchain, and your data will be updated. Okay, so your latest data is going to reflect as I am Pradnyashil. It is no more going to reflect as I am Chaitra. You can you can update it, but it is not like you can't edit it, because up to 2022 your name will still, it'll be the previous name. We need to have this history. It is not like I'm born like this. It needs to have the history of saying I was born I was born with a different name, now I have changed. This is where the whole concept of authenticity also comes into place. If you want to edit it, then anyone can come and edit it. It is not going to allow for you to edit. It is only going to let you update it. So I can claim that I'm a farmer and I have grown these apples, like organic apples without any pesticides and everything. But if you're allowing someone else to say, okay, now this organic market is no more working, I'm going to keep it in this big basket, then someone else can come and edit in the blockchain saying, this is destroy the entire data on how it was grown from an organic farm. You can't do that. It is going to again corrupt the whole system, the whole authenticity of the product. It can only be updated saying, okay, it was grown by organic farmer by so and so reason. It has been distributed to this network because it has been sold there. So we are seeing it here. We can only perform updation. You're getting my point?
Yes, I'm getting it.
Yeah, okay. So that's the reason. You like whatever data you put. Okay, say like by mistake I put a wrong spelling instead of Chaitra. I just put like this, and then this hash has been generated and it's been there in the blockchain. But now I want to correct it. So what I'm going to do, I'm going to put a request for a transaction saying I had earlier identity data like so and so in so and so block. So this data is the actual data for that block. So I'm again going to put this data with this hash. So every time whenever anyone in the blockchain network is going to check my identity, the latest they're going to see this I am Chaitra only. But if they dig up on the history, if they try to check with the previous hashes, it is going to show this whatever earlier data that I had put. So the reason for that I would have stated it was a wrong spelling mistake. By mistake it was done. So that is why I have updated back to my actual name. So there is a way to correct such kind of mishaps that can happen using blockchain, but there is no way that I'll be able to delete my history that I had put with the wrong name. Okay, that we have to be mindful if you don't want that to be reflected. Okay.
Okay. Ma'am, it's case sensitive and it will count the space also.
Yes, everything. So now it is like this 4066. I'm just going to make this capital C, small c. You can see how the hash change. So any character, space or anything, even if I remove the space, okay, I just it says I am Chaitra. See, and you need to uh, observe here, like every time I'm putting this case sensitive one, and every time I'm putting these characters, I'm getting the exact same hash that was generated. Okay, no matter where you put, anywhere with SHA-256 hash generator, these characters is going to generate the same hash. The same way, say if in case I just forget, see, just type in space, it is generating a different hash. So it will take as entire for us. It is just seen as I am just one same thing. For the hashing algorithm, each character is taken with its own the 42-bit, it is taken into count and it is generating this alphanumeric hash. So each character will be taken into count. So that's the reason nobody can corrupt it. Nobody can come back and whatever data I have put, if someone tries to remove the space also, it can't happen. Then the hash changes. Once the hash changes, then the next block that is linked to it cannot validate it, and it's going to disagree with this data, and it cannot be changed at all. It's not going to allow the transaction to pass at all.
Yeah, that's the
Okay.
beauty of SSH 256.
Exactly. Yeah. So I highly recommend mastering Bitcoin. I can show you guys the wonderful book, okay, by Andres. By book, read this all this concept on hashing, and he has even demonstrated how this hashing, even this normal C, how the C has been hashed and put and formed the 64-bit. He has shown everything. Okay, if like if you want to dig
Can we
deeper,
get
this is
these books in PDF form?
I think you can dig up in case if there is any video form available. I just referred like on a hard copy. So just check out if there is any video form. I think it must be available there out there somewhere. Nowadays you get everything, so I don't think it should be an issue. Okay. Now like proof of work. Okay, so when I was telling like how how the miner, and by the way, the first block is called as Genesis block. Okay, it is not the block number zero, whichever we have. It's called as Genesis block. So now when a new block is being added to the blockchain, I told the miners they need to validate. They first before validating, they need to the person whoever is trying to mine the block, he has to do some computational work, and then once he put the block in the blockchain, the others they'll have to validate he has to receive majority from the majority minus the validation. So what exactly, okay, this miner is going to compute, that you should have in mind, right? So this is one of the protocols that is out there. The it is one majorly a Bitcoin that was released using the blockchain technology. It used proof of work concept. So let me explain you what this protocol does. Okay, let me just try to maximize this. I don't know if I'm able to do that. Okay. Okay, for some reason I'm not able to do this. Let me have it in my folder. Okay, I'll just do it for you. Proof of work. Yeah. So how this whole concept of adding a block to blockchain works? What does the actual miner do? Okay, so say the miners are just sitting, and then they get a request saying, okay, there's a transaction that needs to be added into the blockchain. So what is he going to do? He is going to run a few computations. When I say computations, what I mean, as I showed earlier, okay, here you can see each block, it has something called as noise. So each time what he will have to he'll have to generate this number, this noise. Okay, where one noise that can match to a target. There'll be a certain target that will be set. Each time of it will be changing. That like when we get deeper into the concept that I will explain you in detail. So he will have to generate this noise that will be like it'll be in integer format, which will be like above the target that has been set in order to add the block to the blockchain. Once he generate this noise, okay, he will have to take the previous block, whatever header that is there, he'll have to take that, and then he will have to generate using the noise. He'll have to generate another hash number where this hash, if it is less than the target value that is set for the for mining the block into the blockchain, then again it will go back again, he will go back again. Okay, let me minimize this. Again he's going to go back again, he has to generate noise, and then with each noise he get, he's going to follow the same procedure until and unless this whatever the target value is greater than whatever the hash number that he has generated. Only if this value is greater, it has reached above the targeted value that has been set in the for the miners, only then he will be able to add the block to the blockchain. And once it has been added, it won't once he has not added, once he has mined the block to be added to the blockchain, others have to verify the block, whatever the work that miner has done now, the others, the majority, they have to give a verification saying whatever is done right. So only then it will be approved and it will be added to the blockchain, and only then the miner will get a reward for mining the block. Okay, So this is like very important. You need to understand if someone is going to come and you're going to tell like, okay, this is how a block is going to get added. Like he'll do some computation and then he's going to add, and someone comes, अरे minor क्या होता है, what he's going to do, what computation is going to do, what like what mathematical genius is he supposed to be? There's nothing like that. Okay, he will have a set of hardware configurations that is needed, where it has to be so fast. Okay, the hardware configurations of the system has to be so fast that he should be able to generate he should be able to take the previous block header, and then he should be able to generate this noise and combine and form a hash number for which that is supposed to be greater than the target value. If it is less than the target value, then again he's going to go back and then he's again going to generate a different nonce and take the previous block data, and then again going to generate a different hash number. And then if it is like again like greater than the target value, again he's going to go back. Each time you can see na, this loop of getting generating a noise that is greater than the target value. It keeps going on. Okay, only until if it is less, only then he will be able to mine the block. Mine the block, what is the meaning when I tell mine the block? Only then he will be able to add whatever transaction he has taken into the block. Every block, I must tell you this, each block doesn't mean it will have only one transaction. Okay, it depends upon the data size. If just like a small data that I am adding, then there'll be the miner will can take up, there is a limit set for each block size. It can be 5 MB, 1 MB, or whatever. There'll be some size limit for each block. So say like I'm giving multiple requests. I'm going to give, I'm Chaitra, then I'm going to transfer 10,000 to Praneshil. Then again I'm going to have a song that is my favorite and I want to put it in the blockchain. I have so many data that has to be included in the blockchain, so I'm going to send out multiple requests. Okay, so just I am Chaitra, data that has to be fed to blockchain, that is not going to take consume a lot amount of space to be included in the blockchain, right? So what the miner is going to do, he's going to select a all these set of transactions that he will be able to accommodate in his block, that will be within the size of the block, that is probably less than 5 MB or 1 MB or whatever. He's going to take only those transactions. And also you will have to consider this also, like whatever the gas fee that you are going to offer for the miner to add these data into the block. So obviously the miner, he wants a good amount of fee for adding it. So he's going to take some if not very high, at least some medium set of gas fee. So any transaction that you're going to do in the blockchain, you have to keep this in mind, that you're not going to offer very low gas fee. In that case, probably your transaction might take like a very long time, meaning like the miners can take your transaction will be a very last option for them to take up and to be added in the block. Or if it is like a very delayed process, then your transaction will get dropped out only. It won't be successful because you're offering very low gas fee. Okay, so based on this gas fee and based on the transaction data size, these miners, they are going to select these transactions and they are going to include into the block. And to include in the block, this is the exact computation that he's going to do. Okay, he's going to take your data and then he's going to take the previous block data. He's going to generate a noise, and with that hash number, based on based on if it is less than or greater than the target, he will if it is less, then he will be like if it is greater, he will be going on doing this whole loop again, generating noise again and again. And if it is like, yeah, if it is less than the target value, then his proof of work is achieved, then his consensus protocol is done. So then he will be able to add those transactions in the block. Then he would sorry block. Then he would have be able to mine the block. So once the block is mined, then the other miners, they are going to verify it, and then they are going to approve that block, saying okay, whatever he has done, the noise that he has generated, it is definitely less than the target value. So yeah, we can add this block to the blockchain. and once it has been added to the blockchain, only then he will be receiving his reward. This is like a very core concept. You guys really need to understand this. Is there any doubt regarding this?
Ma'am, what is eh, hello?
Yes, yes, yeah, you're audible.
Yeah, ma'am, I'm नॉन्स का कंसेप्ट तो मैडम थोड़ा क्लियर नहीं हुआ है.
Nonce,
What is exactly nonce?
nonce. Okay, you don't I'll tell you, nonce is nothing but a set of numbers. Bas, that's all. Nothing
Okay.
else. Just a number. They have just given the name nonce for this set of number. Okay, I
Okay.
think nonce in some other like Greek or something, it just means number itself. They have just named it as nonce. Okay.
Okay, ma'am.
So it is
Okay.
just a set of numbers, but the main concept that you have to know is this set of numbers, if it is less than or greater than the target value, this is one validation that you'll have to keep in mind for the miner to mine the block. Okay, this is the main computation that he will do.
Okay, ma'am.
Okay.
Ma'am, what happen if two miners are trying to mine at the same time?
You can mine. I am mining, you are mining, but
Yeah.
the main concept comes like who will achieve this nonce
Yeah,
which is
yeah, that's
less
right.
than target, right?
No, actually, I'm saying, if two miners are mining the same block, and
Mhm.
uh, which one is my like select that kind of if
Yeah, yeah, I got
I
your
got
question.
are you getting my
Yeah, I got your question. So what happened? Say like we both we everyone, since it's a distributed network,
yes ma'am.
whoever like the transaction comes, everyone will be able to see the transaction. So I'll be taking up the transaction and I will be able I will be trying to mine a block. Even you will be taking the transaction and you will be trying to mine the block. What happens is, say at the same time,
Yeah,
okay,
at the same time.
you see here, since it's not, you can see here creation timestamp. Okay,
Mhm.
so one filter happens when based on the creation timestamp. So whoever has mined first, their block will be included in the blockchain. But in case since this timestamp is on the basis of seconds, so in case like both have been mined and both have been approved by the other miners also, and both are having the same timestamp, so what happens in that case?
Yes ma'am.
Okay, so in that case, say I have added a block, say A, and there is like ABC. Okay,
Mhm.
let me use this notepad. Okay, I have Chaitra, and what's your name?
Amit.
Okay, Amit. So initially, when we try to before starting mining, we both are having the same blocks. Acha.
Yes.
So now I mined B. Okay.
Okay.
You also added the same transaction and then even you mined E. Okay. And we both, okay, say we own, oh, so sorry, E. So, and our both blocks have the same timestamp and both are verified, but we won't be getting the reward. I'll tell you why. Now there is a conflict. There is someone else. Okay.
Mhm.
Prajna is there. Even he is a part of blockchain.
Yes,
He will
yes ma'am.
have ABC. Okay. So now he will be not sure which block has to be added to his
Yes, yes,
blockchain because
yes ma'am.
both blocks are same.
Both blocks
Okay.
are same. The
Yeah,
same.
and the timestamp is same. So in that case, we have a concept of longest blockchain
Yeah,
concept,
Yes.
where see now
consensus
we
protocol.
both yeah, so now we both have added this. So in case I achieve to mine another block before you, okay, say
Mm.
I achieve this F before you, then Pradnya, he is going to accept my blockchain to the net to his network. Okay,
Yes.
in
Longest
case, yeah,
blockchain is
longest blockchain will get accepted. So
Okay.
basically
What about
considered.
blockchain? What about E?
Oh, yeah. In that
Um,
case, once Pradnya is going to accept my blockchain, then this this E is called as the orphan block. So we are going to drop that block. Since the majority people are going to accept this blockchain network, so you will be forced, Amit, you will be forced to accept this blockchain only. Your E block, even though you have mined, even though you have mined it correctly with the right amount of data, and you have honestly mined it without any corrupted data, still your block, it will be dropped. Now E will be like called as the orphan block.
Okay, ma'am. About what about reward? Actually, I think I mined that block. If I get any reward for mining that,
No, you won't be getting, because it is not accepted in the blockchain. Because
I mean,
I achieved to a block to mine another block before you did.
okay,
So your reward will be lost.
and your reward, you will get a reward for
Yeah,
that.
I'll be getting the reward.
Acha, acha.
Yeah.
Okay.
So that will happen. Okay. So this case does happen. So this is one of the case where this is usually rare, because the amount of transaction and everything in to happen this orphan block, no, this
and what about re- uh, remaining blocks that created by uh, Amit?
yeah, the block that he had created, that is the E block that he had created, we have dropped that block. It will be left out as an orphan block.
And ABCD? What
ABCD
about
will be,
ABCD?
ABCD is there in the network. It is accepted as majority. I am, since I am having this, since Chaitra is having the majority of the blocks, it will be accepted across the network by everyone else.
Okay, okay, get it.
So basically, here the majority, and the one who mines faster for the next block, they win. That's it. And
Hello,
here,
ma'am.
yeah, yeah.
Yeah, ma'am. Like these both okay, and each have their own blocks. So when the while the gets like they're also right. So if they access the same block, why would they like if Chaitra get first and Amit get second? Like I don't understand because they are both accessing their own block, right? Their own their own file.
Actually,
Actually, it's not between those two people.
Longest chain.
Actually, there are so many people in the network. Whenever most of the people get whoever blockchain, like if they get Amit's blockchain, they'll follow Amit's blockchain. If they get Chaitra's blockchain, they follow the Chaitra's blockchain. Whenever one exits the other thing is invalidated, and the longest one will win.
See, you need
Here,
to
ma'am,
understand
just to explain that, ma'am, just to explain, she said she got it. It really doesn't happen like that. It happens when one outnumber the other, I guess, as far as I understand. Is it, ma'am?
Yeah. See, what he told was exactly right. You need to understand the concept of distributed. If it doesn't matter, I'm Chaitra, he's Amit, he's Pragna, or you, it doesn't matter whoever it is. Okay, we are all going to share the same blockchain. Okay, that is why it's called as a shared distributed ledger.
distributed in nature.
Okay, so if I am having ABC, he's also going to have ABC. He's not going to have ABD because he's Amit. Okay, it is not depending on the individual. Whatever the network it is there, it is distributed across all the nodes.
Yeah, ma'am.
Okay, it is not going to matter that way. It's only going to matter,
With same data.
yeah, and it's going to only matter on whoever has the longest chain that is accepted across the network. That's all.
Get it, get it.
Yeah, ma'am, I just have one question. So there is involvement of miners in between the every transaction. So there is a time gap, right? So there is a delay between transactions, right?
Yeah, I know like what you're getting to. So like yeah, we have noise, we have this target that is there, that even on the timestamp. So this delay, whatever you're telling, the that is where the timestamp concept comes into picture. So even with the timestamp, then this delay is covered up.
Okay.
Okay,
Okay.
so that
Yeah.
okay. So I think I'm taking up some time. So let me just introduce Satoshi and the Ethereum blockchain, since I had this. This was the main, probably I can share you this URL. This is the white paper that was first submitted by Satoshi Nakamoto. Okay, this is the main introduction to Bitcoin or the blockchain network. Okay, let me try to open this. Okay. So anyone can go up to this bitcoin.pdf. You will find the white paper that was submitted by Satoshi Nakamoto. This is that anonymous person who introduced blockchain to the entire world. Okay, this was actually published on 2008, October 31st. Okay, so this Bitcoin, a peer-to-peer electronic cash system. This paper, it was he or she, we still don't know because it is anonymous. It was published saying like we are going to, you if you remember during 2008, if someone has watched this there was this movie also made. We had this complete recession going on during that time. What is that movie called? Yeah, The Big Shot. If someone has watched that movie, there's a movie called Big Shot. Okay, that movie illustrates how that whole recession is. It like how that recession happened and everything. So what had happened is like people were just taking loans, and banks thought like they were just giving out loans to people with higher interest. So banks were under the impression like, "Acha, okay, fine, I'm just going to give money, but with anyway higher interest he's going to pay me back." And people, they just thought like, okay, fine, we can take how much of our loans we want, and they just took. There was no verification and everything done. It was like, if you know this financial basis on the system, how a AAA bond works, a AA bond, I'm not going to get in detail. You can watch that movie, or if you can read about it also, it's good. So during that time, this white paper was published by Satoshi Nakamoto, where he thought, or okay, he or she, that person thought that it can be like a solution to this entire whatever the financial crisis that had happened, okay, in 2008. He thought that this was the answer. Okay, how he did that was he designed this one where uh, like a monetary system which will be able to balance both the and chain supply and demand chain. And it was, the best part of it was that it was completely decentralized, and it was no way corruptible. Okay, that is where this concept of blockchain came. So his main intention was to basically, how I explained on the concept of blockchain, was to eliminate that third party, trust based person that is there behind every transaction. He just wanted to eliminate that. And how he achieved that is by giving it authority to each and every person. That is by decentralizing the power and making it completely transparent. That is making it incorruptible. Okay, so how he did is uh, like he created this crazy person. He just created this electronic cash. I like when you read this paper, you feel like how did he even come across the system? He has explained like so much in detail how this electronic cash is going to work without any need of any third party across the whole world. Okay, he how he accomplished is because he created one main asset, that is bitcoin, which allowed this peer-to-peer transaction to happen, and which obviously it's like immutable, and any data it is corrupted through cryptography only to protect any kind of frauding. Okay, so that's when this whole concept of blockchain was created. And if someone wants to transfer bitcoin from say from to another user of this blockchain, okay, from one user to another user, the network would verify whoever is sending it first. Okay, the sender first, and then whoever the receiver would be there, right, even they would be verified and confirm, and then they would confirm that they're transferring to the receiver, whoever is the future block is there. They would then verify it, and then they would confirm. So in this way, whatever the network that amount it will be there will no longer be there in the sender's fund with an like it was irreversible to transfer to the receiver, and so on, like he made sure that this whole transaction is incorruptible. This is about it. Like you can just go through this paper. I can share you the link. This is basically the whole concept that I explained right now. How he's achieving this immutability. How he's eliminating. How he's going to carry out this transaction by eliminating a third party, and how each and every node with the hardware or the CPU power that they have, they can account for the majority of the network, and how the honesty and the integrity of the network can be maintained also. Okay, so this timestamp, this is the exact thing that I was telling, and proof of work node, this is all the thing that I've explained. It's the exact thing how the bitcoin was there earlier and everything, all these things. Okay, you can just go through it. It's a very nice paper. There are many videos trying to explain this concept much further. You can just go through it. Okay,
Ma'am, what happen if all the bitcoins are mined?
it can't that can't be done.
I read that research paper. It's like it's mentioned that all the bitcoins are mined in 2148. But
Hmm.
what after that? I mean, this is.
Why don't you find out that answer for me? Okay.
Actually, I thought maybe you will.
Like he has set a limit of 21 million. So only up to that you can mine.
Yeah,
So
yeah,
you find out you anyway
yeah.
tomorrow next session we are going to meet. You find out and you're going to
Sure,
tell
sure.
me and everyone else like
Okay.
how the supply demand cycle is going to be maintained.
Yeah, actually,
Excuse
actually,
me. After that, you will get rewards.
Yeah.
yeah.
Like only rewards. We are.
Ma'am, I don't understand what rewards, like it's playing game or like something.
Rewards meaning like since this is on Ethereum blockchain, he will sorry if it, since it is on Bitcoin, he'll be earning some bitcoins as rewards.
By doing what?
By mining, by adding blocks to the blockchain, the he will be getting rewards
If you
as
are,
bitcoin.
yeah, if you are putting your, PC or some node to the blockchain and you mined for, you mine some blocks, will get rewarded with the same.
Uh, like if you are doing something, you need you'll get something to do it, right?
Yes.
You're coming to this meet so that you can learn blockchain, about blockchain. So it's an incentive, like prompting people to do blockchain, propagate the blockchain kind of thing. I think you get it.
Yeah, I get it.
This is anonymous guy that is there, like our Baba Satoshi Nakamoto. I just call him Baba Satoshi Nakamoto. So next, okay. So since the whole concentration now, the whole purpose of this blockchain workshop was more on developing a on the Ethereum blockchain. So this is Vitalik Buterin, who first proposed, who again wrote a paper just like Satoshi Nakamoto, and he introduced Ethereum blockchain, where it had retained all the concepts of blockchain, but few changes, where he made the entire blockchain the same decentralized network, the same immutable distributed ledger that was there, where he added where how are we how can we use this ledger by having a programming functionality introduced to it. So that's where the concept of smart contract came into place. I hope some people knew on like when like this DAO attack and all happened. There are some interesting stories on it. Like anyone knows on this DAO folk?
Yeah.
Yeah, yeah. Can you just tell to everyone how actually it happened? And it is quite interesting, very interesting, and it was such a huge controversy that time back then. Can someone tell on this DAO folk like how this DAO attack happened?
I mean, someone basically used the. I mean, it's a code actually, and someone basically found a loophole in that and used it for financial gains and like uh, took so much of money from that, and then it was poured into Ethereum and some.
Yeah, yeah.
A similar thing is happened with Luna as well. I think
That was
if
so
if you know about Luna, Terra Luna.
yeah, yeah,
It's all about algorithmic loopholes.
yeah. Um, so basically, for people who don't know, DAOs are like there was this one German startup that was there, uh, who which used to raise money. Okay, so there was one organization which was there in a German startup, which was built on the concept of DAO. So basically, DAO is something where the investors, there will be certain amount of investors, just like how companies, we have here company, and then we are going to put some amount of, we are going to invest some amount on that company, and then we get a part, we get a share of it. So similarly, how DAO works is like the investors, they're going to give some ether to the DAO, to that organization, which like who in return they use to give the DAO tokens. So whatever the organization, those tokens would be there, that would be distributed to the investor, and the investor would give ethers to the DAO, like on which these investors, they could use it in voting for different policies. Okay, that the DAO would propose. So they can use this ether and this tokens, okay, for for their voting purpose. So if there is any investment proposal that is given by the DAO, so the investor, if they want to be a investor, you can give some ether, and then you can receive some DAO tokens, and this DAO tokens can be used to vote for that proposal if you're for it or against it or whatever. So there was one this German startup. They had built on this concept of DAO, and what they did is like, as he told, there was some loophole in the smart contract. Okay, and like hackers or any users, they can basically smart contract once you're deployed to Ethereum blockchain. It is like an open ledger, so anyone can view the smart contract. So anyone can actually find the loophole also. So they, what they did, they took up this smart contract, they found this loophole, and they used it to take up whatever this DAO had collected. Okay, it was somewhere around April 2016. Okay, you can see this. It happened somewhere in April 2016. This DAO was live. Then they had somewhere in April. Then in the next month, by next month, they had already raised 100 million.
100 million. Yeah.
Yeah. And then again after 1 month in June, that this DAO attack happened. And
Yeah. Ma'am, it's
this, yeah, they
16,
had to
16
this,
June.
yeah, and then they had to do this hard forking for that. So what happened? So certain number of people. So since there was already a loophole in smart contract, the some people in the network, okay, in the Ethereum network, some people, there was no choice for them. See, there is already attack, and some person is already taking up whatever the money they had collected. So in order to stop it, in the Ethereum blockchain, they had to go against this policy of immutability, and they had to go, and then they had to make the correction, meaning they had to change the smart contract. So they did change the smart contract in order to stop this attack, because there was no other way. And the part is like, some people, some part of the network, they believed like, how can you go against this concept? The main concept of this blockchain is, being immutable, and you're going against it. We are not going to approve it. And some people did approve it. And since then, Ethereum is not just one. There is this Ethereum Classic. You can see the icon is also, whatever logo they use is also different. That will be in green, and this Ethereum logo will be in black. So
Yeah.
that's where like the two different Ethereum blockchains was formed. So it's actually called hard forking. So one
Yes.
people whoever believed like, once you put a smart contract or whatever you put in the blockchain, it's supposed to follow this immutability. So it's supposed to be immutable. Those people, that network is still going on. If you go and see, you can still see Ethereum Classic. It is there in with a green diamond shape. And then there is actual Ethereum, where people all agreed on this smart to put down the smart contract and change it. And they have continued as Ethereum now. So that was one interesting attack that happened. So that's the reason, like, if you're more aspiring to be a smart contract developer, what I feel is like, you have to be responsible for whatever you're going to put on blockchain. That's the reason, when you're developing anything, make sure you run enough amount of tests over it. Okay. And crypto kitties,
मैम ये
yeah.
मैम ये सब मतलब डाउ अटैक होने के बाद बाद में ये
Hmm.
सब हार्ड फोक वगैरह इंट्रोड्यूस हुए थे क्या मैडम कि पहले ही मतलब ये
That was actually the first time, huh? That was the first time, like they made the change in the network, like officially, like, and the net, any blockchain that had got divided, that was the first time.
ओके
Okay. So some basic um differences that you need to know. There was another protocol called proof of stake. Just like how like earlier, just by adding another block, like just by making it faster, the like I would earn the block, and the majority of them would follow, right? That uh, based on proof of work, I would have proved that the mine is the longest chain, and everyone else would have got accepted it. There is Ethereum. It recently, this year, some few months back, like this proof of stake was introduced, where there were many disadvantages that proof of work was facing. Like uh, each of the miners, they had to have this hardware configuration. And uh, there was so many, already so many mines have been blocks have been mined, and all the bitcoins have been used up, so they couldn't proceed with the same thing, because they had to have this a huge amount of hardware setup in order to mine more, and in order to be more efficient in the mining. So that's where the concept of proof of stake came, and also it was taking a lot of time when it comes to proof of work. So proof of stake is something like the same concept applies here, where the majority one, whoever in the network, whatever the majority agrees, that is going to be set up in the network. But the thing is, like, you no more had to have this huge hardware setup that with very fast GPUs and CPUs and all that, where the power consumption would also have been more. So here, in order to validate or mine the block, you had to have stake, in the sense like the amount of ether that you're able to put at stake in order to mine the block. So earlier, how it was happening, based on how fast you can mine the block, would be dependent on your hardware. Now how it would be dependent on is like whatever the ether that you're going to keep in place, saying like I am going to put two ethers in the place in order to mine the block. So in case I mine the block, then I get my amount back and some reward. But like whatever, in case that mining it fails, then my two ether will be gone to the network. So in that way, like proof of stake started. Now I think it's working on proof of stake. This is much better than proof of work, and the validation and everything takes place much faster. But the thing is here, instead of the validators receiving that block reward, they used to collect the whole whatever transaction fee itself as the reward. Before, like the miner, when he mines, he used to get their the reward, right? Now on the transaction, whatever gas fee is there, that he'll be getting a reward along with the whatever stake he would have put on hold to mine the block. So that's about proof of work and proof of stake. And just for information, like Ethereum and blockchain are two different Ethereum and Bitcoin are two different blockchains. So please don't get confused. The Even though both have the you know they both are blockchains, the main concepts of blockchain, immutability, shared and distributed, it's going to be there. But both of them are different. You can't program in blockchain. You can program in Ethereum. Okay, that's where the smart contracts come into picture. And since the time proof of stake has been introduced, so even the transactions are much faster here in Ethereum than compared to blockchain. And these are few points that I have just listed out. Like there is some limited size in Bitcoin blockchain, but here it will just Ethereum, it will so it might take much longer time. So Ethereum, it takes less amount of time. And yeah, the scripting language here, it provides a scripting language which is like, it is not being used much, and it has huge amount of limitations when it comes to Bitcoin. But it's because of solidity that in Ethereum we are able to create programs and achieve lot amount of things in Ethereum. That's where Ethereum came into picture with a huge amount of use case, because we are able to program it in any way we want, and maintaining the transparency in the network. Okay. So yeah, solidity is the, as I told, it's like the main programming language that is required to for writing in the Ethereum blockchain. This is for smart contract. I can show you that there is also, like, you can see Mhm. So the latest version is 0.8 currently. So you can see like it is a object oriented high level language which is used for implementing smart contracts. Okay, it governs the behavior of accounts within the Ethereum state. Probably I can let you know by you will know like by tomorrow what is like a state and everything. So this crowding, voting, and these are some of its applications. So in it is static typed, supports inheritance libraries. If you don't understand, don't worry. We can cover it in the next session. You will be able to understand all this. Okay, and yeah, um, this I there is Remix IDE is one. This Remix IDE is it's like very different from other IDE. If you're working as a developer, you can see like how Java it has a separate IDE, then C Sharp it has a separate IDE. So this Remix IDE is totally different, where we can write our smart contracts and we can deploy it even in the blockchain. Okay, so it is a browser-based IDE. You can even download it, but not necessarily. Um, Probably we can. I can show you some. You know how this smart contracts are written, and we can start some hands-on on this tomorrow. Okay, I'll can go through this remix tomorrow. Any questions for the session?
I think if you have any question, you can ask.
Okay, good. Okay, in that case, since nobody has a question, I have a question. Okay. Since we are going to start on Solidity and Remix, like I tell you that you can deploy this smart contract, like you can write smart contracts in Remix and deploy it even to the mainnet. Okay. So how are we going to do that? So there is one thing called as Ethereum virtual machine. So probably you guys can look up what is Ethereum virtual machine, and probably next session you guys can come and let me know how this compiling and deploying is happening in Remix and how Ethereum virtual machine is a part of it. Okay.
Okay, ma'am.
There's no any more questions. I would like to thank you, ma'am, for this informative and amazing session. And thanks to everyone for joining us today. We will start the session tomorrow at the same time. And if you please join our Discord community. The link is given in the chat for the latest updates about our events, and follow us on all social medias. Thank you. Good night.
Good night.
Yeah, thank you.
Thank you. Thank you. Thank you all. Thank you, Anshu. Thank you, Akhil.
Thank you, ma'am.
Good night, ma'am.
Thank you. Good night.
Good night, everyone.